Hey everyone, welcome back. Well, in last video, we talked about a lot of things and ended with consistency levels, right? So Cosmos DB provides 5 levels of consistency, which are strong consistency, bounded staleness consistency, session, consistent prefix, and eventual. There are 5 levels of consistency, and you can choose the kind of consistency you want for your application. So it's a lot of options. It's interesting, and as per your need or as per your application's demand, you can opt for that. Now, this video may be little bigger than usual because we need to complete all these 5 latencies. So let's see. We'll try to talk about these consistency first, and then I'll share my screen and I'll take you through the musical node uh, provided by the Azure to understand the concept. Okay, so let's understand the strong consistency first. So follow the name. Okay, strong consistency. That means the data would be consistent, doesn't mean from where you are reading it. It's that simple. Updating data at the same time means you would not be able to read at the same time. You know, point. For example, you updated in West US and you're reading it from the Japan. In strong consistency, it will take time. So your Japan user gotta wait for a few seconds until the latest data is there to read. So you have to compromise on the availability, and there would be a little more latency as compared to the other consistencies. So this is what the strong consistency is in plain words. So the data is synchronously replicated to all the replicas in real time. This mode of consistency is useful for applications that cannot tolerate any data loss in case of downtime. Hence, the recovery point objective is zero here, RPO, which is meant for data, how much data you afford to lose. The application that cannot afford to lose any data, strong consistency is the right choice for those kind of application. And this strong consistency offers a linearizability guarantee. That's a tough word to pronounce, but what does that mean? This means the order of operation is preserved and the reads are guaranteed to return the most recent version of the item in the database. The client always gets the latest changes in the data when requested. However, with strong consistency, there is a substantial increase in latency since every write must be replicated and communicated to the other regions. It may be one or more than one. So as I mentioned earlier, the longer the distance between the replicas, the longer the time it takes to write the changes to the database, hence increased latency. Okay. So this is the first consistency. Let me talk about the eventual consistency because it is exactly opposite of the strong. Because in strong, everyone was getting the updated data. The consistency is strong. But in eventual, as the name says, if we focus on the name, data would be consistent eventually, but the availability is must. So it's just opposite to the strong eventual, where there is no guarantee you can read the data, but not necessarily the updated one. So no guarantee for the latest data, but the availability would be the highest. Whenever you request, you would have the data available to read. It may be old. So eventual consistency is the weakest consistency level of all. The first thing to consider in this model is that there is no guarantee on the order of the data as well. Okay, there's two things. There is order and there is latest data, because it's so many things, right? So in eventual consistency, even the order is not maintained. For example, if there are three writes A, B, C in the same order, so it may possible in eventual consistent application, you might have C before A or B. Okay, so order is not maintained, no guarantee for the order as well. So in nutshell, this model offers high availability, but and low latency, because it won't wait. Eventually, it's going to have this. All the regions would have the same data, so there is no latency, low latency, along with the highest throughput of all. This model suits the application that does not require any ordering guarantee. If you could guess what kind of applications are those? Of course, where is no financial thing is involved, but like the tweets, what I'm saying, tweets, likes, like the social media websites where those trading is happening, like likes, comments, those things. So it is fine. Eventually, everybody has, all the likes that they have got. It doesn't matter, which like is first, which like is last. Eventually, it would be okay, but it's not hampering any financial loss or any medical urgencies involved. You understand what I'm saying, right? So that is eventual. So that's why I picked the strong first and eventual first, next. So it's the exact opposite. Now let's talk about consistent prefix. So it's not necessary that you will read the updated data, but you will read it in order. Take the same example. There are like three updates, A, then B, then C. So whenever you are trying to read in case of consistent prefix, it may possible you are not getting the updated data, but it is not possible that it's not in order. So if A, B, C are three updates in order, you will get A, B, C in consistent prefix. It may take time. It may not be updated one, but it will be in order. So the replicas guarantee the consistency in order, okay? In order of the writes. However, the data is not always current. This model ensures that the user never sees an out of order write. Okay, put that example in your mind, and you could easily relate with this consistency. Now, this was a third, right? Just keep in mind, strong is where the consistency is taking the preference, eventual where availability is taking the preference, and this consistent prefix where it's kind of, consistency in order, but availability is there. See, kind of mix. Now, session consistency, which is the default consistency of Cosmos DB. Session means that within the session, you will see the most consistent data or most updated data. But outside the session, it is only guaranteed that you will see that consistent prefixed data. consistent prefix, the same consistency that we talked about, means in order. So there are sessions in the session consistency, and all the regions which fall in that session would have the same strong consistency, but the other region, there may be a delay in the data update, but it will always be in order. Okay. All right. So the last one is bounded staleness consistency. So in bounded staleness, data is replicated asynchronously within a predetermined staleness window. Here we are defining a window, like after this particular period of time or particular number of writes, it will start replicating asynchronously. So the read query may lag by either a certain number of writes or predefined time period that we have chosen knowingly, consciously. However, the reads are guaranteed to honor the sequence of the data. Okay, so it is kind of mixture of all, right? So as the stateless window approach, the data replication is triggered on the database account, making the database to update the new entries since the last change. Okay, so this is last bounded staleness consistency. So let me quickly share my screen and take you through the magical node which is provided by the Microsoft to understand these consistency, and it is there when you create your Cosmos DB and check the consistency level. Let me quickly share my screen then. There we go. I hope you can see my screen. Do you see my mouse? Yeah, cool. Now we are on the Microsoft documentation, and this is the strong consistency. Now, what I was talking about, you can follow the node and you can understand all the concepts that I talked about till now. Strong consistency, you can see West US write, West US read, East US and Australia East. Everybody is getting the same data. Let's suppose this node is the data update or the write. You see, red, 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 blue, blue, blue at the same time. So it's maintaining the consistency, right? So in summary, with strong consistency, you get the highest consistency, lower performance, lowest availability. The latency is also high, and this type of model is best suited for inventory applications, financial transactions, scheduling or forecasting workload. Because let's suppose this is a share market application, so you don't want people to get the different information. You want everybody to have the same information. It involves billions of you know, dollars or pounds maybe. So that's how you can see the strong consistency. Now let's quickly go ahead and scroll it down. Then we talked about the eventual because it was absolutely opposite of the strong. So let me quickly go to the eventual first. So this is the eventual. You see, right is happening here in the West US, but you see it's not in order. The black one is here. Here is the black, but here you got the green. You see, eventually at the end, all these rights would come to all these regions, but it may be in different orders, right? So that was the eventual, but it provides the highest availability and low latency. Now let's check the consistent prefix. Now here you can see red, 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 blue, blue, blue. You see, it is maintaining the order. That's what we said. You might not reading the updated data. For example, here in East US, this guy is not reading the updated data at this time, where West US, this user can read the data, updated data, even Australia East as well. This guy is reading here, but the in order. exactly in the order the write is happening: red, blue, purple, red, blue, purple. Okay, there was the consistent prefix. Now afterwards we talked about the session consistency, which was the default consistency of Cosmos DB, right? In session consistency, if you just follow the nodes, session A, session A, session A, session B. In session A, it is strongly consistent, but in session B, there is a lag, but order is maintained. That's why we mentioned the consistent prefix here, right? Because order is maintained here. In session B, because session B started later than the session A. That's why there is a lag, but once it is started, it's all in order. So in summary, session consistency provides strong consistency for the session, ensuring the data stays up to the date for any active read-write session. The availability of data is relatively high with lower latency and higher throughput than the bounded staleness. The possible candidate for this kind of model could be a typical e-commerce application, social media app, and other similar services with persistent user connections. Then after session, we have the last, which is bounded staleness consistency. In bounded staleness consistency, just follow the nodes and you would have everything in your mind, because there is a 5 second, after 5 seconds, it triggers the window and everything is happening. Like these two are consistent together, and here after 5 seconds, it triggers and it's updating these two as well. So it's maintaining the order and updating the database after a defined time period. So that is bounded staleness consistency. So in summary, the data is consistent beyond the user defined time or operations, like number of 100 writes or something like that. The performance of bounded staleness is better than the strong consistency. However, the availability is still low due to inherent lag of the replication. This level is used for apps that don't need to fetch data in real time, however, still in the order it was written. So these are the 5 consistency level that we tried to understand. I know it's very confusing because it's almost like this and that, this and that, this and that, right? But I would request you go through the video again, and this is the link I'll share in the description box. Go to the link if you think you are confused, or if I could manage to explain it well, then it's cool, it's good. Happy learning. Well, thank you for watching and you have a good day. Bye-bye.